we just talked for a little bit about artificial intelligence. So, having said all of this stuff about artificial intelligence and how it's, probably not going to, destroy all human work, let us talk about how artificial intelligence interacts with course policy here. So, it is my expectation in this classroom that you will not take my assignments, run them through the accursed algorithm, take the output of that, submit that as your own work, because it is not your own work. Alright? It is corporate global hyper copyright infringement. That is what ChatGPT is, right? It is not your own work. And contrary to what you may have been told about it, it does not generate unique solutions. And this is actually the crux of it, right? ChatGPT does not generate unique solutions. All it does is it finds things similar to what it thinks you're asking for, and that's even anthropomorphizing it too much because the thing doesn't think, it's fancy autocomplete, right? It's fancy, pretentious autocomplete. It does not generate unique solutions. What it does is it takes existing solutions, cuts them up, rams them back together again with a certain degree of randomness, and gives it back to you. It is a true fact that when students take assignments, run them through the infernal algorithm, give me the result again, I catch them on standard plagiarism checking. That is to say, in many cases, when somebody has done that with ChatGPT, the software that we use for standard plagiarism checking, which is standard at the college, it's called Turnitin, right? Have you guys seen this before? They might have used it in HTML and CSS, right? No? Something? Well, anyway. What Turnitin is doing is it's basically just taking your work and comparing it to the work of your peers to see how much of an overlap there is, right? Where people have just taken the direct output of ChatGPT and submitted it as their own work, you are unlikely to be the only one to have done so. In such cases, your work has, in some cases, matched, not yours specifically, people I've convicted of plagiarism in the past. Previous plagiarism convictions which I've done have been ChatGPT solutions which have ranked in at like 85–90% similarity to other work submitted by completely unrelated people in completely unrelated sections, right? Now, the way that the plagiarism policy works at this institution is I do not need to demonstrate how the plagiarism occurred. All I need to do is demonstrate that the plagiarism occurred. And under the existing plagiarism policy, if your work is that similar to somebody else's work, and I don't just go on the Turnitin score, like I do actually go through and read it and make sure that Turnitin isn't like giving me junk, which occasionally it does. Although, if Turnitin is giving me a 90 or higher, it's like, yeah, it's usually pretty accurate at that level. If your work is that similar, I don't really care if you shared work with your peer, if you both used a common internet source, such as the well-known plagiarism websites Chegg and Course Hero, or if you generated it. By the way, Chegg and Course Hero are only plagiarism sites. There is no legitimate use of them. or if you generated it, you both generated it with ChatGPT, it's all the same in my book. Your work is too similar to someone else's to be a coincidence. You didn't do your own work. Plagiarism charge. Am I making myself clear? Good. In this way, we try to verify that you have done your own work, at least to some degree. Now, you know, for any of you who think I'm blowing smoke about doing plagiarism convictions, I am not. Ask around, and you'll find out that Moore does convict. All right. Last semester, I had 3 sections of server side, and I think I had about 16 or 18 plagiarism cases that I prosecuted across that semester, including 2 that were cheating on the exam. That was fun. And of course, that's a 3rd semester course. In theory, the students in that course have already been filtered by this semester. So generally speaking, plagiarism rates are generally higher in 1st and 2nd semester than in subsequent semesters. So sometimes it's been where, like when I've been teaching Java, a few sections I've done, 30 or 30 odd plagiarism convictions. Normally, it's somewhere around a 1/3 of the class that eventually gets one. Now, it is my fondest hope that I will not have to engage in such proceedings against any one of you. All right? But, just for the sake of us and this video, let's lay it out. How do you avoid plagiarism? Number 1, you do your own work. All right? When you start an assignment, you start it from a blank page. And I realize that this is more difficult. In general, but that's not really saying much, because the whole incentive to cheat is that it's easier to cheat than to do your own work. So it's really no good saying, oh, it's, I can't start from a blank page. That's hard. It's like, yes, this is hard. This is coursework, You are intended to learn something. The harder it is, and the more you suffer, the more you will learn. So, start from a blank page. Don't ask ChatGPT to give you a solution, and it's like, oh, I read the solution, and now I'm going to do my own work. It's like, no. Don't generate a solution for yourself. It's bad policy. And it'll also interfere with your own learning, right? In elementary school, when you were learning your times tables, right? And you had a quiz on your times tables. Did the teacher put the times table up on the board while you were doing your quiz? Hopefully not. I don't know. It's been a long time since I've been in elementary school. But yeah, so number 1, do your own work. All right? Number 2, do not share your work. All right? It is not your job to get your stupid friends through college. All right? They must do their own work too. Everybody is expected to perform at the same level. All right? Do not share your work, even after the deadline. All right? Sometimes, I've had this as well with plagiarism cases, where someone shared their work with someone that was past the deadline, but that person got like a medical extension, and they then plagiarized it anyways, right? It's quite rare, but I have seen that happen. So don't share your work. Also, the assignments in this class, and pretty much any other class that you're taking, are not good portfolio projects, right? The value to your career of putting your assignment solutions up on GitHub is quite low. Any employer who knows coding at all can spot an assignment from a class a mile off, right? If you want good portfolio projects, my recommendation is to come join me for the Video Game Development Club, which is held Fridays from 2 to 4 in E112. That's where we're meeting this semester. If you want a good project for your portfolio, you got to do something outside class. Aside from the capstone also counts for a portfolio project. But you have to do something outside of class, right? Because think about it. Who's your competition? This is your competition. Is your assignment solution differentiating you from everybody else in this room? No. Right? You got to do something outside class, right? So, don't share your work. And if I may say so, for the love of dear sweet Jesus Christ and all that is holy, do not share your laptop with people. All right? If your friend does not have a computer to work on and wants to use yours, make them a damn user account that's separate from yours. Give them their own password. You can do this on any computer, all right? Don't give them your password. Computers can have multiple users, all right? You don't have to all be logged in as the same user, all right? Okay? Multiple users? Yes? Okay? Don't share your bloody passwords? Ugh. You can tell I've been recently traumatized by that one, right? Any questions so far? Does that all seem clear as mud? Anybody starting off this course with the intention to cheat? No? Okay. You had a question? Yes?
What was the class number for the game club?
The class number for which, sorry?
Game club?
Oh, it's not a class, it's just an extracurricular club. I've got posters up around campus.
What?
Oh, the room number,
Yeah.
E112. E112 this semester. Yeah, we're having our first club meeting at 2 today. Please come by. It's a cool thing. At the end of last semester, we did a re-implementation of Tetris. Am I right?
Yeah, we were stuck on trying to figure out how to rotate it.
Oh, we weren't stuck. We just ran out of time. If you want, I can pull it up and finish it for you. Or perhaps we can leave that as an exercise to the reader, eh? Game Dev Club, we're just a bunch of cool people who like video games. Don't come in thinking you'll make God of War or Civilization 7. Start small, all right? Start small and build up. Anyway, so if you're not scared by the plagiarism policy out of your nefarious ways, there is one more thing that you should be very, very aware of looming over the horizon. In this class, 75% of your final grade is assignments. We have 5 assignments. Quick maths, how much percent is that each? 15, thank you very much. So each assignment is worth 15% of your final grade. In addition, there is a final examination that is worth 25% of your final grade. This final exam will be closed book, no computers, just a piece of paper and a pencil and your brain. All right? If you don't pass it, you don't pass the course. All right? So, if you have done all of your assignments all semester by smudging together pieces of code you found on the internet and not actually learning anything, you will not pass the course. You need to actually do your own work. That is the thing at the end that is checking to make sure that you have been learning things. Now, that sounds difficult. It sounds scary. Let me throw a few reassurances at you that the exam itself is not quite as scary as all of that. Some people get the impression that, like, when I say the test is pen and paper, that, like, I'm somehow not aware that the test is pen and paper. You know, like, I know coding on paper has its own set of challenges, right? There are a lot of things that we rely on, things like the compiler or autocompletes, right? We rely on these as tools while we're developing software, right? Those tools are not going to be available on the final exam. Therefore, my expectations for how syntactically correct your programs are therefore lowered, right? I am not going to be taking marks away from you for missing semicolons. Wait, you guys have only done Python. You guys have done a little Java at this point, right?
Yeah.
Have you seen a semicolon? Okay, good. All right. Semicolons, if you forget a semicolon, it's not the end of the world. Don't sweat it. Mismatched braces, I don't really care, right? The things I care about on a written coding test are you performing the right operations to complete the assigned task, right? Are you applying the wrong operations to the wrong data, right? Did you get the overall structure correctly? Or not even correct, but would it work? See, a thing that, a thing that some professors will do, which I strongly disagree with, is they will expect you to, like, come up with the solution they have in their head or that was given to them in the solutions, right? They'll expect you to reproduce that solution to the line, right? Perhaps you've encountered this, perhaps you haven't. Lord only knows what happened in fundamentals last semester, I suppose. I am not like that. If your program works, it is correct, regardless how you constructed it. I'm not expecting you to read my mind to come up with the specific solution that I thought of when I was writing the program, or writing the question. If your program would perform the computation correctly, mostly, you'll be fine, right? The grading on these questions kind of goes like this, right? At the bottom end, well, obviously you have to answer the question to get any marks, right? So at the very bottom end is you left the question blank, 0 marks. The next step up from that is you kind of have no idea about basic syntax. Somehow you've managed to do an entire course and you're like coding in like a conglomeration of 3 other languages other than the one we actually learned in class, right? Like 1, maybe 1.5 out of 10, right? If it's obvious you have no bloody idea what you're doing. And by the way, it's generally speaking that category that the policy that you must pass the exam is designed for, right? If you have gotten 90% on all of your assignments and you get 7% on when you actually have to write something down, you don't know anything, right? You may think you know something, but you don't actually know anything, right? Because in order for you to know something, you need to know it on a test, right? If you can't produce the information from your brain, you don't actually know it, right? So, if you clearly don't know, if you don't know Java from JavaScript, you're not going to score well on the test. Next up from that, you kind of have like some idea what's going on, but you've either badly misinterpreted the question or you fundamentally don't understand what's being asked, right? This will be like a 3 to a 4, right? Your algorithm is nowhere near to doing what it is supposed to be doing, right? When you start entering into like, okay, I'll pass you on the question territory, it's like, okay, you've understood the question, right? Your code is junk, right? Very poorly written. It doesn't do what you intend it to do, but I can tell what you intended it to do and it's not doing that. We're kind of talking like a 5 or a 6 out of 10, right? Code that has like some important errors but is generally correct, we're talking like, somewhere between a 6 and an 8. And then, a couple of small errors to no errors at all, that's kind of your 9 or your 10 out of 10. Does that make sense? Have I assuaged your anxiety in any way? No? Still anxious? Well, as I always say, the best preparation for the exam is the course. Oh, by the way, here we go. Here's your final exam. I've got it right here in my briefcase. No, I'm not going to do the final exam on the first day of class. That would be cruel. Although it might be interesting, to compare how much you didn't know at the beginning of the course. We never test people at the beginning of the course to see how little they know. And so you never get to see like how much more you know at the end of the course. But anyway. So, any questions about that? Okay. Further sort of special course policy territory. We have a late days policy in this class, similarly to Java. My understanding is that in Java, you are limited to a maximum of 2 late days per assignment, and you have 10 total. In this class, you still have, no?
Yeah.
Yeah? Okay. In this class, you still have a total of 10. You have a maximum of 3 on any one assignment. But otherwise, it's the same policy. Any questions? Okay. Assignment submission. What time is it actually? Okay. We're doing okay. Assignment submission. You will be required to make your assignment submissions to both CS Unix and to Canvas. This should be fairly similar to how things worked in HTML and CSS. This is a class on web programming. You will need to deploy your work to an actual real live web server. In the private folder of it, I think everybody should be on board with this. Is anybody, a couple of people in the last class kind of mysteriously, I think they were desynchronized, they didn't get the HTML, CSS with CS Unix. Is everybody cool with CS Unix? Is everyone down with Apache servers? Okay. Mostly? Alright. Good. So, the purpose of this is twofold. Number one, it is important for you to get deployment skills. It is also important for you to realize that you need to test things before you call the day done and the job finished, right? It is not sufficient that your work works on your own laptop or on the lab computer. If it's broken when you upload it to Apache, it is broken and it needs to be fixed. Now, if it's something simple, like uploading it to the wrong folder, there is a grace period. Basically, I will send an email if your submission to CS Unix has not been made correctly for whatever reason. I'll send you an email and you have 1 week to correct the submission, after which it'll just be a 0. Fair? Okay. Did they do the same thing in HTML, CSS? The 1 week submission thing? Okay. So I'm not saying anything new then. No?
I think they just did, late game.
Oh. So here's the problem, right? Here's the problem with CS Unix. Timestamps, like timestamps on files, are meaningless. There is a very, very easy and simple bash command called touch, which allows you to modify a timestamp inside of a Linux environment to anything you choose. I could make it so that my files were uploaded to the server in, January 7th of 1972, if I wanted to, right? It doesn't, like, timestamps are not proof that you had your work in on time. So, when you are trying to argue with me that you did get your work on time and you send me screenshots of timestamps, I will say timestamps are meaningless. If it wasn't submitted to Canvas, it wasn't done on time. All right? There are two purposes, well, there are three purposes to the Canvas submission. Number one, that is your official submission time. Right? Official submission time. Number two, it allows us to do the plagiarism checking. That's where that system lives. And number three, the Canvas submission is used to authenticate your CS Unix submission. I have a little bash script. That bash script takes all of your submissions from Canvas and compares them to what you uploaded to the server. If there's a mismatch, I will tell you, somewhat sternly, to upload the exact version that you uploaded to CS Unix, or to Canvas, onto CS Unix. No sneaky business, no shenanigans. Don't you try to get your bug fixes in after the deadline, because I will know. I'm looking, I'm watching, always watching. All right? Question?
I have a question about the late days. How far over into the day does it count as a late day? Like up to 10 minutes over, is that a whole late day? Or?
I generally give you an hour.
Okay.
If you're like keep it close, but if it's up to an hour after midnight, I'm not gonna fuss myself about it. That being said, when the Dropbox closes, it closes at midnight. So that won't apply to the last possible moment of submission. Sound good?
Yeah.
That's a very good question. Any other questions? Any more intelligent questions, such as the last one? Okay. What was I talking about? CS Unix? Yes. So, when you submit, I am using your Canvas submission to verify that your CS Unix submission is that is the copy that you submitted to Canvas. So don't try to sneak your bug fixes in. I will know. I'm like Santa Claus, right? I've got my magic crystal snowball. That's called a bash script. So, good. Any questions? Yeah.
So the final exam, I assume it'll go over like the stuff we covered in the 5 assignments?
Yes, there is going to also be some knowledge questions about the covered material in class. But you can, I'm comfortable saying that for coding questions, they certainly will be assignment related for the most part. Now, I haven't actually written the exam yet, right? So I can't tell you what the exact contents of the exam are, and I would ask you to re-ask your question within a couple of weeks of it, right? But yeah, it's a little too early to be worrying about the exam. Right now, we should be worrying about JavaScript, So, any other questions? This kind of concludes the course policy segment of the presentation. Anyone? Everybody clearly understands what's being expected of them? Okay. All right. Good. Wonderful. So, oh, and by the way, the classes are 3 hours long. That's a long time to talk, even for me. So at some point, at some convenient point in the middle, we will have a 15-minute break in these classes, and that will be our habit. I do tend sometimes to ramble a little bit. So if we're kind of running over time for the break and I haven't given you one yet, I probably just forgot. So just put your hand up, and I will be happy to give you guys a break. Sound good? Good. So. So let's talk fundamentals. Not programming fundamentals, JavaScript fundamentals. So the general organization of the course is that for the first module, if you look at the modules on Canvas, you'll see that the first module is kind of recapitulating some information on HTML and CSS. Now, this is not intended to be doing that course over again. We will be focusing on those issues that are directly relevant to JavaScript programming. So, and well, in a general sense, JavaScript programming requires a very heavy degree of knowledge of HTML and CSS. So, if you didn't do that great in HTML and CSS, it is well worth your time right now, not like right now, but this weekend, brush up on it, all right? Go make yourself a couple of simple web pages, go through the W3 Schools quiz, right? Brush up on your HTML and your CSS, because yeah, pretty disgusting, right? Everything we do here in JavaScript will require some degree of, usually HTML, sometimes CSS, but normally HTML. All right? Good. So, overall structure, we're going to talk about HTML, CSS. We will do a certain amount on the CSS framework Bootstrap, which I hope everybody finds useful. We will then go to the JavaScript material, JavaScript proper. We will hang out there for some number of weeks. Probably that'll last us until after the midterm recess. We will then talk about the document object model manipulation, object-oriented concerns in JavaScript. We will learn that through the medium of SVG graphics. We'll have a component where we do some SVG graphics. And after that, we will be talking about AJAX requests. AJAX requests are the final and most difficult of all of these modules. It requires knowledge of network stuff in advance of everything else. Everything else we're kind of like, you know, this is client-side programming. We're going to stay in the client most of the time. But for those topics in particular, or that topic in particular, AJAX, what Ajax is it's a communication with the server. So we need to know something about communicating with the server to do that. We're gonna have to talk about packets, etc. So, that's the course. After that, we'll have the exam. You guys will have summer. And then, after your summer, assuming you pass, you will be taking server-side programming. Possibly also with me. So if you don't like me, too bad. You'll have me for probably just about a year. Well, I don't know. We'll see how it goes. I don't know what my schedule is for the fall yet, but it's entirely like it's very highly probable I'll be teaching at least some server side, as I'm planning a reasonably large revision of that course over the summer to ditch PHP and bring it up into the modern era, bring it up to Node.js. I'm fighting at the moment tooth and nail to try to get that deliverable in the fall of this year. There are a couple of like interesting prerequisite problems with it though, which, you know, it's kind of like above your pay grade, but perhaps this is interesting. So server-side programming, right? You would think that this class would be prerequisite for that, right? Client-side should be a prerequisite of server-side. It turns out no. Somehow the way the program of study was designed, Java is the prerequisite for server-side and not client-side, strangely. Which, you know, I won't criticize too heavily the decisions made by my predecessors, but if we are converting it from PHP, the old crusty bad language, into Node.js, the new fun fresh language, Node.js, the JS on it stands for JavaScript. It makes sense that this course is now, you know, even more the obvious direct prerequisite to server-side, right? JavaScript now in both courses. So we're changing, we're part of that process is to change over the prerequisite. But of course, we actually have a contractual and ministry obligation to offer to you guys the program of study that you signed up for in September, right? So, at least for the first offering of this newly revised version of server-side, I have to offer that in such a way that you can fail this course and still take it, right? So basically it'll need a few weeks dedicated to JavaScript semantics that, you know, we're going to do here, but we're going to have to do it there again. That's like my working solution right now for being able to roll Node out for 2025. So, you know, there might be a little bit of repetition for you guys, but I think that, like, getting Node in under your belts is, like, it's sufficiently advantageous over continuing PHP that, you know, we can do a couple of weeks of review of JavaScript and it's not going to be that big a deal. Like, I don't know, like, if you guys are trying to get, like, co-ops or anything, or jobs, you know, maybe a couple of you are interested in getting jobs in a related field, but, like, Node is, like, currently the most popular server-side framework. Like, a lot of people are using it, and a lot of people are no longer using PHP, right? In fact, almost nobody uses vanilla PHP anymore. When you see PHP used, it's usually either WordPress or Laravel, and in neither of those cases are you really directly using vanilla PHP, right? You're using a framework written in PHP, which is not quite the same thing. Like, you should still know PHP to do that, but, you know, so it goes. If PHP sounds like a great idea to you, though, despite the fact that I'm really doing my hardest to sell it, right? we do still have an upper semester option. It's currently called Advanced PHP, but like it'll have to be renamed to like just PHP, right? That's a course where the Laravel framework is taught. It will, at that point, have to also cover like the basics of PHP once we take it out of server side. But if you want PHP on your resume, there's a course for that. We're not getting rid of PHP from the program, right? We're just like, we want to get Node onto your resumes before we send you guys out for co-ops, right? So that's kind of the motivation behind the change. And honestly, probably overdue. Although converting it to Node, Node's actually pretty recent. Like it's about 10 years old, right? 5 years ago, it might not have been the right way to go if we made this change. But because when these things are like very new, they are in phases of rapid development, rapid change, which means that like on our end, the curriculum would have to be like almost completely thrown out every year, which, you know, it's stabilized now, right? So the knowledge we give you in class will last a bit longer. It's, you know, it's a bit more stable now, so it's a good time. It's a good time to bring Node into the program. But yeah, so that's kind of, I guess that's neither here nor there, but excuse me. So, but we are a very long way off from talking about server-side programming because we don't even know any JavaScript yet. So, you all took networking fundamentals, right? So everyone should be able to tell me the difference between a client and a server, right? Anybody? What's the difference between a client and a server?
Server hosts a service or client accesses.
Yeah, so the client accesses the server and the server serves things, right? What were you going to say?
Practically the same.
Practically the same thing. Good. So, in general, you will, over the course of your tenure with me, get used to this diagram. Right? We have the client, we have the server. All right? When communication happens between the client and the server, who initiates communication? Who starts off the communication?
Client.
The client, yes, very good. So the client sends a packet. What's that packet called?
Hop.
Starts with an R.
Request?
Request, there we go. The client sends a request packet to the server, right? So, okay. As I occasionally have to say to my 2-year-old daughter, I hear your request, just tell me what you want. What are you requesting? All right? What is the client requesting from the server?
Access to the service.
Access to a service? This is a more modern
The
view.
service.
Yeah, so if you're thinking things in terms of like APIs, right? You're correct. We're not there yet. We're kind of thinking more in like web classic terms, right? What is a request? Don't worry, we'll get there. But like let's lay the foundations first. What is a request? What are we requesting? A page. What is a page?
Like it sends, I think it said an IP.
The The, yeah, the IP address is the location at which these guys exist on the network. We are software people. We do not have to worry about all of that networking gobbledygook. All right? We exist in the pure realm of software. Hardware might as well not exist to us. So, not IP addresses. I heard someone in the back say something.
So you're basically trying to get some form of data.
Some form of data. Very good. Where do we store data? In files, yes. So, request. Request is actually short for request for remote resource. Right? Again, once we start talking about APIs, things get a little bit fuzzy, right? But all of these like REST APIs and modern ways of thinking about things are fundamentally still built on the same structure, right? Which is HTTP. Can anybody tell me what HTTP stands for? Hypertext Transfer Protocol. What does the S stand for?
Secure.
Very good. So, Hypertext Transfer Protocol. The protocol itself is meant for fetching hypertext. Right? So the question is, what on earth is hypertext? Right? Well, what does HTML stand for? Hypertext Markup Language. Right? So, HTTP was originally a transfer protocol for fetching hypertext documents from servers. Essentially, long way to say it, the internet is one big distributed file system. Right? So, we have HTML, which is Hypertext Markup Language. Question: what does it actually mean to be hypertext? Like, where does the name hypertext derive from? Anybody?
Related to connection. I don't know, but I feel like something related to connection. Because,
Related to connection?
yeah, like
Good guess.
Hyperlinks.
There we go, that's the word I was looking for. So, it's kind of like definitely 90s talk, even 80s talk, to use this term these days. We don't use the term anymore, but at the time when all of this was being decided, we had the concept of links, and we had the concept of hyperlinks. Anybody care to guess what the difference between links and hyperlinks were in the 90s?
Would link be within the same page, and then hyperlink would be to a different page?
Precisely so. Back then, a link was intended to be a link within one document. A hyperlink was intended to be a link to some other document, right? So, hypertext is text containing hyperlinks, right? Hypertext HTTP, Hypertext Transfer Protocol, right? Hopefully things are kind of connecting, right? So this is kind of the original formulation of the internet. Like, you have to understand that, like, the place everything started was HTML, right? By the way, do you know what standard HTML is based on?
The number.
Nope. It's a series of letters. It's another acronym.
Okay, because that's the letters are best fun, but it's
So
not.
HTML is based on a standard called XML. XML stands for Extensible Markup Language. basically XML is HTML's format, but you get to decide what the tag names are. Right? So HTML has specific tag names. XML, it's like a superset. All HTML is XML. It just, you have a set of predefined tag names, right? At the time, XML was it was quite popular back in the day, like Word documents back then, and I believe still to this day, are XML encoded. Like Microsoft Office documents are generally XML encoded, which is partially why they're terrible, by the way. So, extensible markup language. So, essentially, the way things worked in Internet Classic land, you have a request, the server has HTML files, index.html. The request is for a specific thing, right? The server fetches it out of its file system, encodes it as a packet, and kicks it back to the client in the form of a blank packet. What kind of packet?
Response.
Response. Very good. I like this class. You guys are actually participating in the lesson. I like that. So the response packet carries with it in its payload the file that was requested. This is the fundamental basis that everything else was built on in the internet. All right? And even with just plain old HTML, you still have you can still get a certain way with it, right? So, pretty quickly, as the internet developed, people were like, oh, wait, you know what would be cool? You know what would be really cool? We could send images, all right? So, they added things to HTML so that they could send other sorts of things other than just HTML, right? You could link to resources that were not just hypertext. Images being kind of the easy example. So, let's say we have a file called a.jpg, right? The HTML file, when it has the image source tag in it, that actually causes a second request. Any resources that are not contained within the four corners of that HTML document itself must be requested from the server separately. Right? They are separate and different transactions. So, if I get my response back and my browser, let's say because this is this is Internet Classic, let's say this is Netscape Navigator. Look it up. Look it up, all you people who were born later than I was. When your HTML page is interpreted by the browser goes through and says, oh, wait, whoa. You're asking for an image there. I don't have that image. I'd better ask the server. So, it triggers a secondary request to the server, request a.jpg. And the server says, oh, somebody is requesting a.jpg. I have no idea who or where or why, but I am a server. My purpose is to serve. Therefore, I shall respond with a.jpg. Now, in the early days of the internet, sending images around was like most of the network traffic that you had at any given time. Like, the size of an image file was like you would, like, oh man.
Well, it was dial-up back then.
It was dial-up, but like I remember in the tender days of my youth, right? Pokemon was the big thing, you know, not like gold and silver. I'm talking red and blue. All right? And what did I do with my time as a tender youth? I looked at a web page with a picture of every Pokemon on it. And it took about half an hour to load every page. It was actually kind of fun because it wouldn't load them in the order they were in on the page. So you could like kind of scroll back and forth and say, oh, this one's come in. Oh, that one, So yeah, the internet was really slow back in the day. Transferring images around was like about the maximal thing that you could do with it, right? Let alone bloody video. Oh my goodness, can you imagine? Good grief. So now we can load resources that are things other than the web page itself, right? Eventually, this leads us to the idea of, oh, well, you know, HTML is all good and all, but it's ugly as all hell. Maybe we should do something to make it pretty, right? So, thus gets invented the cascading style sheet, right? So cascading style sheets, when they are a separate file, must also be requested from the server in one of these transactions, right? When we eventually get to JavaScript, and I believe JavaScript came before CSS, if I'm recalling things correctly, when we load a JavaScript file, that is also a request for a remote resource that is a separate transaction. So, here's a question for you. This doesn't happen a lot, right? But occasionally, very occasionally, this will happen. You load a web page, right? And it's like a bunch of text along the left-hand side on a white page, right? And it's not formatted at all. It's just like it looks like a bunch of headings, right? But it's like nothing else. And then you're like, this looks like garbage, and you reload the page and everything comes in and it's the website you were asking for, right? What has happened there is that the specific request-response pair that's loading the CSS file has either become sufficiently delayed that you noticed it, or the packet was dropped somehow, right? It can happen. It doesn't happen very much, but packets do get lost in the network, right? So that's what happens there. So let me just finish let me finish this and then we'll go on break. So when we are talking about web development, right? We always have to keep in the back of our minds that we are a client talking to a server, right? Yeah. Actually, I don't think I had much else to say about this. Okay. By the power vested in me by the institution of Mohawk College, I hereby designate a 15-minute break. Please be back here at precisely 11:47. Thank you. Class now resuming. So, Gesundheit. So, I know that according to the modules, we are meant to launch into some HTML material. However, seeing as this is a JavaScript class, I kind of want to like show you guys a little bit of JavaScript first instead. We will, I want to, you guys should at least see a hello world. I always think it's a failure if you don't get to a hello world in the first class, right? So, if you can't do the hello world in one class, your language is probably too complicated. So, JavaScript then. Let's talk a little bit about how, what JavaScript is, where it comes from, why it is the way it is, and that the way that it is terrible. JavaScript is a terrible, terrible, terrible language. Nobody should use it. Despite that fact, it is the most popular programming language. So, let's find out why. First of all, in the last couple of classes, someone in the crowd at some point has wondered, well, I'm taking this class on Java, and I'm taking this class on JavaScript. Why am I taking the same class twice? And my response to that, although nobody asked it, which generally shows your intelligence as a group, I must say, the reason the reason is that they are not the same language, not even close, right? Java is to JavaScript as car is to carpet, all right? They are very different languages that have very different philosophies. Why is JavaScript called JavaScript? Because Java was popular at the time, basically. It's kind of like, it's interesting. You know polka dots? Like the pattern on fabric, polka dots, right? Here, okay. Polka dots, right? Often the polka dots are actually quite a bit larger than this. This is somewhat understated. But have you ever wondered why they're called polka dots? Because what is polka? Anybody know? Come on, somebody has to know what polka is.
A dance?
It is a dance, yes. It's a particular type of kind of Germany sounding bouncy music that involves a lot of tubas, right? It was quite popular about 150, 200 years ago, right? It was such a craze, right? Polka was such a dance craze that a lot of people started marketing products based on polka when it in fact had nothing to do with polka. So fabric manufacturers came up with a new fabric pattern. They called it polka dot. It has nothing to do with polka, although it does have something to do with dots. They marketed it that way, and suddenly the polka dot dress is the thing you wear to the polka dance, right? So the reason I tell you this is that JavaScript suffers a kind of a similar phenomenon here. So you have to kind of cast yourself back into the mind of a software developer of the early 90s, and I mean the very early 90s, right? Java was the new shiznit, all right? Brand new language, very cool language, all right? Java was a big deal when it was originally released. Basically, how programming languages work, their development is programmers read papers published by mathematicians at universities for all of their interesting, fancy new means of doing logic. Then they're like, hey, it'd be cool if that was in a programming language. And then they write a programming language. And that it integrates a bunch of those new features, right? C did this back in the day. C being the granddaddy of all modern programming languages, almost all modern programming languages. and also being the best language of all of the languages, C. So, like C occupies the same position within the family of programming languages that like Latin does in European languages, or like, you know there's this kind of mysterious language that's called like Indo-European that like all languages are based on somehow. That's C. For programming languages, that is C, right? Java comes by, 25, 30 years later, incorporates 25, 30 years of research into logic and mathematics done at universities. This is where you get Java's object-oriented structure from, right? This is where you get things like inheritance and composition, and you get things like, what are they called? Generics, right? Which you probably won't do until right at the very end of Java, if you do them at all. A generic is a type variable. It's very interesting stuff. Like, Java is a very cool language, very highly mathematical, very rigorous language, right? It was the bee's knees. Everybody loved Java. Java was the new thing. It's a little bit like the reaction people have to Rust these days. It's like, oh, Rust is the best language. Hey guys, you want to redo your entire code base in Rust? That'd be a great idea. It's like, well, no. But, Rust has been, making waves, and it's been getting traction. Who knows where Rust will end up, but, right now everything seems to be going kind of in web directions anyways. Somebody's lunch smells delicious. Anyway, so Java did something a little bit different and interesting, or at least it popularized it, right? So, do you guys know the difference between compiled and interpreted languages? Anybody? Care to guess?
In Java, we have to compile.
In Java, you have to compile. That's true. Java is a compiled language. Can anybody care to guess some other languages, whether they're compiled or interpreted?
I don't know, but maybe Python is interpreted.
Python is definitely interpreted. Yeah.
Can I guess the meanings?
Please.
Okay, although compile, just based on the name, I suppose that the system, in a way, save the information, like the code that someone wrote, saved in a kind of, I don't know. In the case of Python, I don't know, maybe the system interpreted what you wrote and then translated to the machine. That's my guess.
That's a good guess. Like, all you're really lacking is the vocabulary for what's going on, and a couple of other pieces. But that's a really good one. So let's play a game. All right? I'll say a language. You put your hands up, and I'll ask you if you think it's compiled or interpreted. Okay? So, we already said Python is interpreted. All right? Is C compiled or interpreted? How many people think compiled? How many people think interpreted? Good instincts. How about C++? Compiled? Interpreted? Based on your answer to C, that's a pretty good guess. JavaScript? Compiled? Interpreted? Yeah, you guys do seem to know what it is. How about C#? Compiled? Interpreted? Compiled in that case, yeah. PHP? Compiled? Interpreted? Interpreted is correct. Very good. So, this is the difference, all right? So, let's imagine that you have your operating system, right? The shell upon which your programs are being run. You have, this will be compiled, right? You have your source code file, star.c. Let's just work with C, you know. In compiled languages, you take that file as input to a process running on the operating system, which is the compiler. One of the most popular C compilers is GCC. The GNU compiler collection, that's the one that runs natively on Linux. You also have Clang, which is the IBM one, and you have, of course, the one which is not to be mentioned, the Windows C compiler. Of these three C compilers, one is not compliant with the C standard specification. I'll let you guys guess which one. So we run our C file into GCC. That program produces as output an executable file. In Windows-like environments, I know I'm like mixing my metaphors, but in a Windows-like environment, executable files will generally have the .exe extension. But do I have any Linux people in the crowd? Oh, that's so disappointing. All of you should eventually be Linux people. On Linux, Unix, Mac, we all know that for a file to be executable, all that really means is that its executable flag has been set. So any file of any file extension can be executable. It doesn't have to be a .exe, you know, Windows. So, nevertheless, when you have your executable file, you execute your executable file, or you run it. That means that the file gets run directly on the operating system as a first-party program. It is just a program running on the operating system directly. Does that make sense? That's compilation. Then, you know, you get output, or it does something, right? It takes input, produces output. Input goes in, output comes out, right? Garbage in, garbage out. You know, the approach I take to my own digestive system. So, we now have interpreted languages. Interpreted. So, in an interpreted language, we still start with a source code file. Let's say .py in this case. Well, now let's make it JavaScript. This is the JavaScript class after all. Right? JavaScript source code file. Right? Now, in order to execute, you need an interpreter process running. It's a bit different from having a compiler. So, as we know, JavaScript runs on web pages. Web pages are loaded by what? Browsers. Very good. So we have our browser, right? The browser runs a sub-process, which is the JavaScript interpreter. So on top of the browser, we have the JS interpreter. That's far enough. And into this interpreter, you feed your file, one line at a time. This is a very important thing to know about interpreted languages. Compiled languages, you throw the whole file in all at once. Interpreted languages, you are feeding one line at a time into the interpreter, right? We then have input going in and output coming out. We never produce an executable file. That's the main difference between interpreters and compilers. Compilers will produce an executable file. Interpreters will not. There are a couple of important side effects of this, right? When you are installing a program on your computer, I know this is like a little bit passé these days, actually installing software, but when you are installing software, you are often enough compiling it, right? When you install the software, you compile it once, you produce the executable, you can run that many times. Yes?
And I suppose that you can move the executable file from software to software, like from one computer to another one?
Often these days, yes. Going back historically, the executable, so you have to understand what the executable is, like what is in it. And the answer is machine code, right? Instructions for the actual CPU of your computer, right? Now, different computers have different CPUs. Different CPUs have different instruction sets. In general, like this used to be a lot worse back in the day. These days, things have pretty uniform architecture, right? But an Intel chip is going to have one architecture. An AMD chip is going to have a different architecture as well. And then an ARM-based CPU will have a different instruction set as well, right? So it's not so much that anymore that you can, like, an executable compiled on something of the same architecture will work on a different computer. You can just throw the executable on a USB stick and plug it in, it'll run. If you're trying to do that with a different CPU architecture, it won't work, right? Like for example, if you compile something on your laptop, get that file onto your phone and try to run it, probably won't work. Does that make sense? Back in the day, every computer had a different instruction set. So you had to recompile your files for every different computer.
And I suppose that like the compiler have like a, I suppose like a list of like, in a way the compiler need to know which type of architecture your device is using to compile the file, right?
Well, it did, actually. In these days, you had a slightly different version of the compiler for each architecture. This is actually the great innovation that the C programming language made. Prior to C, you actually had to write slightly different programs for each architecture, which in those days meant every different type of computer you wanted your program to run on, you had to write that file, you had to write that program for that computer, right? You'd have to take your, you'd have to take your program for your PDP-11, right? And if you wanted it to run on like a ZX Spectrum or something, you had to re-implement vast quantities of code, right? C comes along, and it's like, hey guys, here's an idea. Wait till you hear this. Write the program once, compile it everywhere. Ooh. So now code becomes shareable between architectures. This is how C led to the development of the Unix operating system, which was developed at Bell Labs and distributed for free to educational institutions, where it became like the standard way of doing things. And then Unix was basically like the first good operating system, and like, I digress. But yeah, C was like, okay, we will have one file, right? We will compile it once. We will compile it for each different architecture, and then the executable, like you can share code that way. Great idea. Fantastic innovation, right? So now let's talk about Java. Java is a little bit different. I know this isn't the class on Java, but you know, this is probably going to be of interest. So Java, as we've previously stated, is a compiled language. But it's also an interpreted language.
There's just one compile and the other places can use it, right?
So, yes. So essentially, as you're going to find out in your Java class, there is a difference between the Java development environment and the Java runtime environment, right? Those are two different packages. The development environment includes the runtime environment, but that basically means that Java files have two of these processes. One is javac, the Java compiler, and the other one is just Java, although that is the Java virtual machine. Java virtual machine, the JVM, right? So a JavaScript, or not JavaScript, a Java file is compiled by the compiler to produce not an executable file, something that's directly executable on CPU, but another sort of intermediary step called a class file. You may have even seen class files already in Java, right? If you dig through some of the weirder directories inside of IntelliJ, you'll be able to find the class files, right? Javac produces class files. The class files are then loaded by the interpreter, which then takes the input and produces the output. Right? So it is both compiled and interpreted. There are advantages to compilation versus interpretation. Anybody care to guess? What are the trade-offs? Let's talk about speed. What do you think is faster, compilation or interpretation? Interpretation is faster. Anybody else? Compilation? Yes, compilation is, like, in terms of how long it takes your program to execute, compilation is way faster, actually.
That's after the compile, like.
After compiling, yeah.
But
Although,
I was comparing, like I was trying to compare it between before the compiler.
oh, like the whole thing?
The whole thing, yeah. So.
Depends on how many times you run this, right?
Okay.
The amount of time it takes to compile is amortized over the number of times you run the program, right? So if you compile once, run 1 million times, then you are actually, like, you can sort of factor it in that, 1/1,000,000th of the time this took to compile is applied to each time you run that, right? So in the end, compilation is faster, right? And certainly, if you're only considering the executable, it's definitely faster. I had a student once who told me that they did a re-implementation of an image processing library that was written in Python. They just did a straight line-for-line re-implementation of it in C++. Guess how much faster it was? Factor of 5. 5 times faster. Same damn algorithm, just not in Python, right? The reason that the reason that interpreted languages are slower is because you're also running all of this process, right? Which is often lots of stuff you don't need, right? Second trade-off. With compiled languages, all of the checking is static checking, right? That means it does things like type checking once, at the beginning, right? This is the way that Java works. You do all of your checking inside of the compiler because the executable only has what you programmed in it, right? It's not doing secondary checks. This means that certain types of processes don't exist, right? One typical example is like Python does runtime type checking, right? When it does type checking, it's doing it at the same time that it's running the program. That's not possible in C, right? In C, you have to do all of that checking up front. But it doesn't so Java is a hybrid, again. It does all of its type checking up front, right? It makes sure that your program is correct before it lets it through to this stage. But then it has a lot of interesting little features that it's running at runtime as well. Java is not as it's faster than Python, but it's still, because it's pre-compiled a lot of stuff, right? It's faster than Python, but it still does have a lot of background processes that are doing things. For example, do you know what the garbage collector is? Have you guys heard of garbage collection? I mean, you've probably heard of it, but not in a programming sense, right? So, as a Java program runs, memory is allocated, and then it's deallocated. Sometimes you lose a reference to some memory, right? In a language like that, that memory just sticks around forever, right? Until the program ends, or if the operating system is doing that. That's actually what a memory leak is, right? When the program is giving itself memory and not giving it back when it's finished, you can imagine over time it just gets more and more and more and more and more, and eventually there's nothing left for the actual operating system. The entire memory, the entire system memory is given over to all of this dead space that this one really terrible program has allocated itself. And then, of course, your operating system has no place to put further memory allocations. So what does it do? No, it doesn't die. It starts caching it to the hard drive. And that, my friends, is the reason why, if you have a Windows machine that's been running for a while, it just suddenly there's a break point where it just starts being really, really slow. It's because the memory's filled up and you're now caching to the hard drive. That's the reason that happens. So garbage collection is, what Java does is it goes through its memory every once in a while, and it looks for things that have been lost but not deallocated, and it deallocates them. It throws the garbage away. It collects it and it throws it out. Garbage collection. That's a thing that it does because it has an interpreter, right? If you wanted that in a C program, you would have to write it yourself, or use a library that does it. Does that make sense? Any questions? So, for JavaScript, we are running an interpreter. So, interpreted languages ordinarily have a command line interface where you can feed it commands one line at a time. This is the same way that it thinks of its own files, right? It thinks of its files as feeding one line in at a time in sequence. All you're doing by using the command interface is throwing a few more commands into the interpreter, right? So, let me show you how to access the JavaScript console. It's very simple. I'm just going to pull up a page which I think is reasonably stable. Wikipedia. Today's featured article is the Ferrari FF. There you go. That is a car. Very good. Made by Italians. Presumably made by Italians. Made in Italy, possibly by Italians. So, I skipped over the tutorial bit. Okay. So, any web page at all, you right click, inspect, console, this is your JavaScript console. I understand you guys have played with the inspector pane a little bit, but probably it's probably mostly still got a bunch of garbage to you, right? largely uninterpreted. As we go through this course and server side, more and more tabs and features will become useful to you. Right? So, the JavaScript console. Using the JavaScript console, one may execute JavaScript over any loaded web page. But it is important to understand the scope of such changes. Right? If I modify this page using JavaScript, in one sense, I have vandalized Wikipedia, but only on my machine. I have not done anything to the server's copy. Obviously, as that would be highly absurd. If entering some commands into the JavaScript console was all it took to modify someone's files on a server, can you imagine the world we would live in? Right? So, JavaScript executes over your locally stored copy of the web page as retrieved from the server. When you reload the page, you are fetching a fresh copy of that page from the server. This kills your current JavaScript session. It kills the interpreter. All variables are lost. All defined functions are lost. Everything is lost, and you get a fresh copy. Does that make sense? Even if it doesn't, we shall see it in action. So, a lot of talk, talking. Do you want to see the hello world?
Yes.
So, there are really three main ways of going about this with JavaScript. The first, and possibly the most basic, is to print to console. Very simple. Console.log. Hello, world. There you have it. Simple. This is the equivalent of your print statement in Python, system.out.println in Java, and yeah, those are like the only two other languages you officially know, right? They didn't sneak any other ones in? No? Okay. So, I highly encourage all of you to open up the console and follow along. That is how you are going to get the most out of the lesson. You actually type the things I have typed. So, console.log is a very useful thing when you're trying to debug something. A thing you will find when you are trying to debug code, diagnose what code is doing, you will want to see what your variables are doing, right? Now, languages that are sort of outside of a web environment will often have nice tools to help you with this, right? Breakpoints, for instance. In web world, you know, possibly there are some add-ons, but in general, this is how you query the state of the program, right? So, for example, if I were to declare a variable, let x equal 5, right? A variable. If I wanted to see the state of 5, or if I wanted to see the state of that variable, you simply type the name of the variable, and it will tell you what's in there. You don't have to say console.logx, at least not here, right? If you're doing JavaScript inside of an actual script file, you should be using console.log. Okay? So far so good? Okay. Now let me show you something that you should probably never do, but it's kind of fun. Alert boxes. Alert boxes are terrible, terrible UI design. Awful UI design. Do not ever use them except in rare circumstances, right? I think the only acceptable use I've ever seen of an alert box being used in a web page I visited is like I was filling out a web form and like I had forgotten a required field and I tried to submit the form and the alert box came up and said, "Hey stupid, you missed one." And I was like, oh okay, click, alright. Sometimes it's easy to, like from a user interface perspective, it's sometimes easy to miss those like, "Hey stupid, you forgot a field" type messages. But in general, if your website is giving your user alert boxes for no reason, you should go home and rethink your life, right? Or at least your approach to user interfaces. So, alert. Hey stupid. You forgot a field. So that is what the alert box does. You see, we get this little pop-up at the top with some text. They have to click OK. Interesting thing about alert boxes is they actually pause the browser's rendering engine. So, for example, if I wanted to close the console, you'll notice the web page is still only occupying half the screen. In order for it to, fit itself to its new width, the rendering engine has to be turned on. The rendering engine is turned off, and in fact, everything is halted as long as that alert box is up. So it's actually kind of a sneaky way to pause your program. If you click OK, everything pops back in. Does that make sense? So far so good? Any questions? Okay. So, and now for the part where I'm sure, the part everybody I'm sure has been waiting for, how do you use this for mischief? Right? So, alert. So if you have any significant others or roommates, particularly if you have ones that are not tech savvy, this is a fun one. Hi, Alexandra. I'm watching you. This is funny because my wife's name is Alexandra. I'm not picking on. If there's anybody in the room whose name is Alexandra, I apologize. I was thinking of my wife. And there you have it. So that's a fun one. However, as pranks go, suboptimal. As when you close the browser window, which clearly shows you what you're doing, even to a normie, there's still evidence left behind that you have done something to the web page. While this is an okay prank, this is still kind of a substandard prank. All right. So, I would now like to show you an absolute masterful level prank. All right. The best prank. The third way of printing information to a website, or using JavaScript, is to print it to the website itself. Right? Put the content on the page. Now, this is something that we're going to go over in more detail later on in the course. I'm not expecting you to pick this up right now. I'm just trying to impress you a little bit with the capabilities of the language. All right? Check this out. All right. So, in JavaScript, we can pull references to page elements. All right? Anybody know a method that you can use to pull references to page elements? Yes?
Get element by ID.
That is the old crusty way of doing it. We will show you the modern method. But yes, get element by ID. Get element by ID assumes that the element has an ID. Right? If you use query selector, you can actually use CSS queries, like CSS filters, right? The thing that starts your CSS rule. You can use those to gather up references to things in your web page. This is the way that this is the direction things are moving. It doesn't actually require an ID anymore, all right? Like you still do use IDs, right? But you're not required to use them anymore. Watch this. Document dot query selector all. Then you specify a CSS selector. Let's say, just for the sake of interest, A. What's A again? What's an HTML A tag?
A link.
It's a link, yes. Yeah, anchor or link. So, there we go. This is a list of all of the links in the page, every one of them. Let's bind that to a variable. Let links equal document.querySelectorAll A. Links is then, you can see, that same list. So, have you guys seen for loops yet? Yeah? Okay. I'm not talking about Python for loops though. Have you guys seen like ordinary regular for loops? Yeah? I'm going to do a for loop. For, let I equal 0. I is less than links dot length. I plus plus. That is an ordinary plain old for loop. This is equivalent, by the way, can you see this in the back?
Yep.
Okay. This is, you guys have better eyesight than I do. Holy smoke. This is basically the same thing as a while loop. Normally you initialize a loop variable. Normally you increment that loop variable. It just collects those other things into the brace so that you don't forget them. That's what the classic for loop is. All right? Don't worry, we will go over this in more detail, and I am absolutely sure that you will do it in Java. All right? So, classic for loop. Links at I. You guys did a little bit of data structures in Python, right? Enough to know what a list is?
Yep.
Yeah? Okay. Links.I dot inner HTML. So inner HTML is everything inside of the tag. Is equal to cheese. There you go. Cheese. The Ferrari FF is a cheese that was produced by the Italian car maker Cheese from 2011 to 2016. The successor to the cheese, the FF, whose name is an cheese for Ferrari 4 cheese. It is a 3-door cheese developed in the, anyway. So, what have I done? Using this loop, I have overwritten the content of every A tag on the page all at once with the slightly humorous word cheese. Is this a hello world? Well, I could have made it say hello world, but I decided cheese instead. So that's one thing you can do. And, you know, just because we're feeling a bit mischievous. Let me see, is my sound turned off? Okay. Look away from the screen for a moment. Yeah. Oh, just watch me. So, modifying inner HTML is one thing. How about modifying href? you can access any attribute of an HTML tag this way. There we go. Now, let's see. Hover. Uh-oh. If we take a look at the preview of the link in the bottom corner. There you go. This, my friends, is one of the purest and truest forms of the Rickroll. You can perform this modification to your roommate/significant other's code, close the browser tab, and unless they are paying attention very carefully to the link at the bottom, which they usually are not, you got them. And even better, right, they're probably not going to open it in a new tab, right? So, when they click the link, the FF was succeeded by the cheese in 2018. What is cheese? Oh, it's a Rickroll. Oh, that's stupid, I'm going back. Oh, it's cached it. Oh, interesting. So, basically, if you reload the page, you're back to the non-Rickroll with every link version of the page. Why? Why did all the Rickrolls go away? Anybody? We already discussed this.
You're requesting a new copy of the original file of the server, right? Every time that you refresh the website.
What were you going to say?
That's what I was gonna say.
Yeah. So refreshing the page closes the interpreter session and opens a fresh one. You are fetching a fresh copy from the server. Any modifications you made locally on your own machine are kaputski. Sound good? Any questions? So far, so good. So, oh, by the way, does anybody want me to put that code on the board so you can,
Yeah.
I expect a full troll report from everybody. Oh, and by the way, for those of you who are unused to command line interfaces, if you use arrow keys in the prompt, it sends you back through your history of entered commands. This can save you a lot of typing. Like, this can save you a lot of typing. So, use the arrow keys, eh? Yeah? Alright. So, step number 1, this one. Step number 2, that one. You may now take your pictures. All right. Everybody good? Okay. So, while vandalizing Wikipedia is fun, unfortunately there's no assignment on it. So we should talk a little bit about our development environment, right? Man, I should write an assignment that's here, vandalize Wikipedia. No. That wouldn't be good. For the purposes of this video recording, I do not advocate internet violence, only rickrolling for the purposes of mischief. So, I don't know, do you consider like actually going in and vandalizing Wikipedia to be internet violence? That might be stretching the term a little bit. Anyway, so, the question might occur to you, okay, so presumably we are going to be required to develop some software. How are we going to do that? Well, basically there are 2 IDEs which I recommend. One or the other of them is fine. Although in general, I try to stay fairly agnostic about what you're actually using to write your programs. You can do it in Notepad for all I care, right? It doesn't have syntax highlighting, but you know. So generally, you've got VS Code and you've got Notepad++, because Microsoft killed Atom. Otherwise, Atom would be a good competitor. You guys know what Atom is, or what it was? So Atom was a lightweight code editor that basically VS Code copied its homework, right? It was like done by the GitHub people, right? Then Microsoft acquired GitHub, and Microsoft was all like, "You guys don't have to worry. We won't shut down Atom. That would be anti-competitive business practice, wouldn't it?" And guess what? 2 years later, they shut down Atom, which is a shame because it was probably the better of the two. But yeah, no, Microsoft wanted to shunt everybody into VS Code, which they've mostly successfully done at this point, unfortunately. So it is beholden upon you, dear viewers, to go find some open source code editor and use that. All right. That being said, you know, VS Code is industry standard. You know, so, you know, despite being run by a giant mega corporation that's really more of a Lovecraftian horror than a real organization by real people. So, you know, VS Code, I will show you how to use it. It kind of interacts badly with Mohawk apps lately. Like Mohawk apps does some kind of, like, it's actually, like, Mohawk apps' verification subroutine is actually, like, it runs pretty frequently, like I think every 30 seconds or something. Like if your computer loses internet, you have like about 30 seconds to a minute to save your work before Mohawk Apps closes your app. Yeah. Welcome to the cloud, my friends. Welcome to always on internet connections, am I right? So, personally, I install everything natively, as you can probably imagine. So, basically, something goes screwy with VS Code at some point during that process, and like, it'll soft lock, but VS Code will, like, Mohawk apps will cause it to soft lock. This isn't going to be a problem if you install it on your own computers, right? But, you know, just be aware on the lab computers, that's a known issue. Happens to me all the time. I think to a lesser degree you, I'm not sure why. But anyway, depending on how my personal level of frustration with VS Code is going throughout the semester, I will probably just change to Notepad++ at some point. So that's like, it doesn't really matter which one of the two you use. I know like some people are like, ooh, VS Code is better than Notepad++. It's like, yeah, you know, it's easier and more convenient. Unfortunately, it's also filled to the brim with evil. So, you know, so it goes. So, let me show you how to do that. Yeah, I'm not done. You thought I was done, didn't you? Now you'll find that I go right to the bell, but not a minute over. I will not have you cut short the time I have out of my day for hearing myself talk. Thank you very much. There we go. So, oh, one other thing while we're on the topic. If any of you have forgotten your CS Unix login credentials, I am the guy. send me an email, I will reset your password. Somehow this is my job, even though IT administers everything else on the server. This is my job for some reason. So send me an email, I will reset your password. Hopefully you didn't all forget them over the Christmas break, but happens every year. So, Visual Studio Code. By the way, Visual Studio, if you've never used it before, Visual Studio and Visual Studio Code are very different programs. Very different programs. VS Code attempts to be a lightweight text editor with, you basically only get frills if you ask for the frills, use it by installing extensions. But anyway, file, new file, index.html. Documents. Yeah. My website's perfect. There we go. Oh, and by the way, if you haven't done so already, the time is now, all you poor, befuddled Windows users. Go into your user account settings on your Windows machines and set it so that you can always see file extensions. Alright? It will save you having to click the little checkbox every time you open File Explorer. Alright? You are software people. You are computers professionals. It's about time that your operating system stopped lying to you about what file extensions your files are. Okay? So, it's okay. I don't hate you guys for using Windows. I just hate your operating system. So, HTML and CSS. My understanding is that they made you memorize the HTML boilerplate. Did they call it the boilerplate?
Well,
No?
call it like that, but yeah.
Yeah.
Easy memorize.
The contents of the header, perhaps? You want to see something fun? I want everybody to watch very carefully. Hold Shift, type an exclamation mark, press Enter.
Oh. Okay.
There's technically missing a
But
line
that will
in
be
that.
visual.
Well, you can add it. You can probably also go into the settings and modify what it gives you, right? But yeah, templates? Templates? Yes, templates. So, in the 4 minutes we have left in class, I will show you how JavaScript can be integrated into an HTML document. Now, on the client, the only language you have available to you is JavaScript. You cannot run Java, you cannot run C, you cannot run Python, you cannot run PHP, you cannot run Node. Just JavaScript. It integrates like this. Script. End script. Just like that. Console.log. Hello, world. By the way, in JavaScript, semicolons are optional. This professor prefers them, because I'm kind of a classic kind of guy like that. JavaScript is integrated into HTML documents using the script tag. When we want to load an external JavaScript file, we will use the source attribute to load that file. This requires an additional going back to the server to ask for an additional resource. But, you know, generally speaking, I'm sure they beat that drum of externalizing things pretty hard for you in HTML, CSS, right? No? Really? A little bit? Okay. You should be putting like actual JavaScript and actual CSS in your actual HTML file almost never. Almost never. You should always put it in its own file. Alright? Why?
Make it like just a part of everything, make it more organized.
Organization, yes, but also that means that multiple pages can use it. Right? Multiple pages can use one set of CSS rules, but only if it's in its own file, right? This is your first very important principle of software design. Do not unnecessarily multiply the code, right? Do not repeat yourself. That's right. Here's the problem, right? I want you to envision a scenario. Let's say you have written a set of 10 lovely HTML documents, each with its own script, or its own style element, its own style tag, right? Let's say you want to make a change. How many places do you have to make that change?
All of them.
10, right? Because we have 10 HTML files.
That.
Are you going to probably make a mistake doing that? Because you are a poor, simple human who makes mistakes? And like a thing that human beings are generally really poor at is like typing the same thing multiple times. You know? Like we make typos. It happens. The fewer instances of that code you have to modify, the more fast and reliable it is to perform changes. This is the same principle behind externalizing CSS code. This is the reason you write functions. This is the reason that object-oriented programming exists. Everything. Right? Write it once, call it elsewhere. Alright? Very important principle. If you really want to impress me, right? Design your own functions, right, in your assignments. Think about how your code will break down modularly and write your own functions I didn't call for. That impresses me, especially at like this level, right? It means that you're beginning to try to think like programmers, right? Okay. Well, that's about all I have for you today. Thank you very much for your time and attention today, folks. Have a good weekend. Oh. It's too late to suck up now.